Good morning, everybody. Welcome to our webinar today. Thanks for joining us. So today's webinar will be hosted by our and it will be around oil condition monitoring. Basically, oil condition monitoring, it's a service which we've been offering since quite a good time, I would say. And yeah, it's quite an important service because it helps you also to kind of also like support you for maintaining your equipment by knowing how is the condition of the oil. You know which preventive measure could you do to prevent actually problem within your equipment. So I think our speaker of today, Sharif Quraish, will be the one giving you more details about the service we will be introducing today. Sharif is our Middle East laboratory manager for our commodities division. He's having more than 30 years experience in laboratories, lab design, training, technical governance, and so on. And he's having a master's degree, bachelor degree in petroleum chemistry, and an MBA actually. Thanks a lot for joining us, Sharif. I'd like to introduce you to the program of today. So we'll be starting by a small introduction, then we'll be speaking about maintenance and failure, setting a program, how the sampling is done, what is like expected from testing and data analysis, how the reporting is done. We'll be also sharing with you a few references. And then, of course, as in all our webinars, we will be having at the end a small session for question and answers. So I'd like first to introduce our webinar modality. So basically, I am requesting everybody in the call to mute your microphone to avoid noise disruption. Something quite important to also mention to you that is the session would be recorded. I think you have already, like you can see already in the screen that the recording has started. And basically by joining our webinar, you are consenting to this. The recording would be shared with the presentation after actually the webinar to all the people who have registered using the registration link. If you face any problem, I kindly request you to contact our marketing communication department using our email address contact.middleeast@bureauveritas.com. And if you have any question, please do not hesitate to use the chat button. Otherwise, at the end of the presentation, you can of course raise your hand or even ask your question like by your own actually, or write it in the chat and we will highlight it to our speaker. I'd like first to introduce you briefly our group. So our group is a world leader in testing, inspection, and certification. We got actually by end of 2019 more than 78,000 employees working in 1,400 offices and laboratories around the globe, and we have reached over 5 billion euro revenue in 2019. In the Middle East region, we are actually proud to say that we've been in the region since more than 50 years. Since more than 50 years. Sharif, please, can you pass to the next slide? I wanted actually to show you the geography where we are present. Sharif? Okay. So basically in the Middle East region, we've been, sorry. I think we have a small technical issue. I'm sorry for that. I'm really sorry, actually, we have a small problem with the slide. Yeah, so basically I wanted just to share with you the map, which is highlighting our presence in the Middle East. So basically, we are having actually more than 54 offices, including 13 laboratories in the 18 countries, which are highlighted in the map here. And we're proud to say that we are one of the largest testing inspection certification company in the region with over 4,000 employees in the geography highlighted in this map, actually. In our commodity division, we are actually offering services like several testing services and of course sampling and inspection 24 hours a day, 365 days a year. We're having areas of expertise, oil and petrochemicals, so trade inspection, laboratory testing, blending cargo treatment, metals and minerals, so we have upstream services, trade services, agri-commodities and fertilizers, so offering same actually testing of grains, vegetable oils, testing of water quality, and so on. So I'd like actually to keep this introduction short. I'd like now to pass actually the word to our speaker today, Sharif. Sharif, the floor is yours. Thank you.
Okay, thank you very much, everybody. I hope you can hear me. If you can hear me, please confirm. Somebody, Nahla, can confirm you can hear me properly?
Yes, that's perfect, Sharif. Thank you.
Okay, this is your screen, right? The screen is now on display.
Yeah, the one commodities we have, Sharif.
Yes.
Yeah.
Okay,
I
brilliant.
have number 7.
There was a disruption in the network, so apparently there is a load on the Teams. But this is your screen, Nahla?
No, it's your screen. You're the one sharing, Sharif.
Okay.
Yeah, so you can pass to the next slide. Sorry.
Okay. Thank you very much.
No worries.
I would like to thank everybody for attending this short webinar on oil condition monitoring programs. And just as an introduction, we as BV is a leading global oil condition monitoring testing laboratory and for services related to this particular projects. And just a definition about the oil condition monitoring program, we are focusing mainly on the oil testing for these programs. As a definition, in-service oil analysis is performed as part of a routine predictive maintenance program to provide meaningful and accurate information on the lubricants conditions and the overall condition of the machines and equipment. Our approach mainly is to provide a unique service, which includes reporting, diagnostics, and of course testing, which will help our clients to have a solid maintenance and predictive maintenance program to start with. Our propositions in this case is offering a partnership with the clients in order to give them experienced data analysis and meaningful recommendations for their programs. We help them in managing their data, and we put them in engagement with our staff in order to have proper communication in this case. So to start with, the services we offer under the umbrella of the oil condition monitoring program, we are testing the fluids which are affecting the machinery operations, and mostly we are talking about diesel as a fuel in certain engines which are using diesel as a fuel or natural gas to some extent, greases which are used for lubrication, and the testing for there is to evaluate the wear consistency and the contamination associated with the grease system. Metalworking fluids, again, in certain applications where metalworking fluids are being used, knowing what is going on with the fluids involved and the wear associated with it is important. Coolants, whenever there is a cooling system involved. Of course, the heart of this is the lube oil, which is basically the use for lubricating the equipment and the moving parts of the equipment at all times. And whenever there are refrigerants, we are having the facility of
Sharif, I'm sorry, but we lost your voice. Hi, Sharif. Actually, we're still facing problem with the voice. I'm really sorry. Actually, we have just some technical issue with connection today.
yeah, that's okay. Can you see the slides, please?
Not yet, Sharif. I think you need to re-share your screen again.
Okay. All right. Can you see the slides again?
Now it's perfect, Sharif. Thank you.
Okay. Sorry for that. Okay. The first section of this webinar will be about maintenance, brief idea about the maintenance failures and the benefits from the oil condition monitoring program. And as all of us would know that there are several methodologies in maintenance methodologies programs which are being used. 4 of them are listed here, which is the failure-based maintenance, FBMs, and the scheduled or preventive maintenance programs, the PMs, predictive maintenance, PDMs, and the proactive maintenance, PAMs. This basically can be discussed later in a different webinar or whatever. But the figure here shows what happens in a machinery when during operations, and basically during the normal conditions, which we are working with now, when the machinery starts to face a little bit of a problem, there will be vibrations, and this vibration can be detected by vibration analysis, which one of the technologies which is been used for predictive maintenance programs. The predictive maintenance programs actually involves mainly 3 technologies: the thermography, measuring the heat energy evolving from the machine, vibration analysis, as well as oil analysis. So once the vibration starts, excessive friction will happen, and then you will be hearing a noise going. You will be hearing this noise going on when the machinery or the equipment is in operation. And due to the friction and maybe misalignment or whatever, you'll be having heat associated, and this can be either sensed by touching or we using heat sensors. And when the problem comes more and more, smoke can be, you can smell it, or visually you can see the smoke coming out of the equipment, and then a breakdown. Nobody wants to reach this breakdown point, which is shown there, and the period or the distance between or the time between the excessive friction happening or where the vibration starts until the smoke is where the actions need to be taken. This slide shows, for example, on this pie chart, we are talking about the maintenance spending, which is part of why people are using predictive or maintenance programs in place. Most of 50% of the equipment actually spending on maintenance are related to instruments, pumps, compressors, mixers, agitators, and valves. So 50% of the expenditure on the cost of maintenance are on these particular items in place. And if we are talking about the refineries, for the losses in the refineries due to mechanical failures, it constitutes 45% of the losses. Other like operational errors, process upsets, natural hazards, and stuff like that are less and less as you go. The predictive maintenance programs is always essential for critical equipment. And these equipment are defined as being capital intensive, or the ones which are having a long life, designed for long life operations. And they are actually made up of many components, several components in place. And of course, their downtime is quite expensive. The causes of failure, here we are talking about machinery as well as the oil in the machines or the equipment. And so we can have a combined causes of failures. So if we are talking about oil-related failures, this can be because of cheap oil, excessive heat, defective formulation means you have an oil which is not matching the specs, ISO grade and stuff like that. Oil aging, the oil has actually exceeded its lifetime. Mixed lubricants, because sometimes people buy from different suppliers, so they are using mixed lubricants, although they might be having the same ISO grade, but possibly the formulation is a little bit not matching, not compatible. Aeration, which be ingression of air into the system, causing bubbling. Metal catalysis, which is chemical change of the oil structure due to the catalytic reactions of the metals involved, plus oil contamination. So these are some of the oil failure related to the machinery itself. When we talk about the machine, it is, of course, you can have a failure due to the machine defect. When there is a repair, this repair was not done properly, inadequate repair, fatigue and overloading, misalignment and unbalance of the equipment while operating, leaks, so the oil will go out and end up with starvation of the oil, means that the oil levels will be down, so the machine is not actually performing properly. So based on the oil failures and the machine failures, we have consequences, and these consequences are related to the cost you might having due to downtime during the oil changes, oil changing costs, operation disturbances, the cost of the labor to change the oil, and of course cleaning the system after a certain maintenance due to the failure itself. And this is, we call it OLC, which is overall lubricant criticality. And when we are talking about something called the overall machine criticality, the OMC, this is actually related to the machine being down. So you have business interruption. There are some safety issues because of the machine itself, and the cost of the spare parts and the repair costs, labor as well as downtimes. So why is OSCM important? OSCM is actually a very important tool, one of the three major tools in the predictive maintenance programs. And the benefits you are going to get from having this program in place is a decrease in the downtimes and for sure increase in productivity. You have a reduction in the maintenance cost, you have effective maintenance planning, and you have an increase in the lifespan of the machinery if this system is put in place properly. And as we said before, BV can help you in putting such a system in place to set up an OCM program which is effective to you to actually have all the benefits we talked about now. So how can we set a program? The initial step in setting the program is having our goals and objectives clear, meaning what do we want from this particular program? Do we want just to have a plan to have regular checks on the equipment, or we want to save costs, or we want to maintain the equipment for a longer period of time and avoid downtimes and stuff like that? Then we decide on the program services, and BV will go through, once you agree on a program like this, BV will go through with you in order to help you setting such a program and putting it into place. Then you have to have proper registration of the equipment with proper identification, and then sampling procedures. BV will advise you what type of sampling procedures is fit for this particular application. So the selection of the equipment is very important. And if you don't have this program in place, you have to follow a certain scheme of work or schedule by starting small, for example, based on the equipment criticality. And these equipment criticalities are the ones which are important to the operations. They are the ones which are large enough. They have, as we mentioned earlier, they are expensive to lose, and they should last for a long period of time. Then you decide on the sampling frequency. It could be monthly, quarterly, or hourly, or by mileage, or whatever. And then we help you by setting up a training program or an awareness program for reviewing the protocols, reviewing the sampling procedures, and reviewing the reports which are produced for the OCM program. And then later on, you expand the program to include more and more equipment once the system is being familiarized with. The required information to set up a program would be having the units and compartment IDs, the manufacturer's makes and models, the information about the oil, like the brand, the isocrate, and the manufacturer of the oil itself, because this gives you the limits and the specifications for the batches you are using, the equipment type and the application it is used for, the environmental condition, and the service hours for the equipment as well as the oil. And when we are talking service hours here, we are talking about the oil change for when we are talking about the oil itself. After the program starts, we will be sitting with you to select what type of package to be tested. BV offers 4 major packages involving several suites of testing. We are offering a basic test package, which, for example, for the diesel engine includes the metal analysis, the viscosity at 100, the FTIR for fuel dilution, soot, glycol, oxidation, nitration, and sulfonation, and water content. We have the standard package, we have the premium package, and the premium plus package. And this is basically depending on the application in use. So if we look at this as an example for the industrial premium test packages, you can see for the diesel and natural gas engines, we are doing metal analysis, as I said, for contamination and debris and additives, viscosity, the FTIR for retransform infrared spectroscopy, water by Carl Fisher, and we can do water by other methods as well. Carl Fisher gives you ppms, and the water, other methods can give you percentages. We are talking about diesel engines base number, and other engines we are using acid number as well. If we are talking about compressors and bearings, we are talking about metal analysis, viscosity at 40, water by Carl Fisher, and we are talking about acid number and particle counter as well for particle size, and the particle quantification if needed for other systems as well. So a critical part of the oil condition monitoring program, OCM, is the sampling. All right? And sampling is the critical aspect of any fluid analysis program. And it is known for laboratories that the testing results are related to the sampling being taken. So basically, it is very critical to the results being produced from the tests. Sampling procedures actually build solid foundation for any analysis. And these graphs show you different machineries and different points where you are taking the samples. And for example, on the right side here, we are using a pump to draw the sample from the fluid itself into the sampling bottle. Okay, we have drain port sampling at the bottom here, and we have sampling from a sump or a tank where we are taking the sample from a middle zone, which is acceptable, of course. But if it is ideal to take it from a pipe which is sitting in the tank itself or the sump. There are certain types of sampling as well from certain points in the system, like point B or point A, but we'll talk about this in the next slide now here. Sampling recommendations, which are supposed to be shared with you along with the sample procedures, are as follows. We avoid points where the flow is restricted or where debris or contaminants are settling down. Meaning, if you have somewhere where there is a potential settlement of debris, you can never take a sample from there. You have to avoid it, and you take it from a place where there are no settlements of debris or contaminant. If you find a sampling point containing debris or contaminants, you have to flush or purge the sample point prior to taking the sample. You have to take the sample while in operation. You don't take a sample from a machine which is out of service or not operating for a long time. Or if you have a shutdown, you have to take a sample 30 minutes, within 30 minutes from the shutdown itself. You need to take the samples from the same sample point every time you sample a certain machinery or equipment. Prior to taking the sample, you have to visually check that your sampling tools and bottles are checked for cleanliness, and again, after dispatch, no leaks and stuff like that. So the program for sampling is actually a simple 3 easy steps. You need to take proper sample. You need to supply all the information regarding the machinery, the oil type, the operation hours or mileages and stuff like that. And this is you can place it on the label here in point 2, and then dispatch the sample for testing using safe and proper procedure for dispatch. So there will be no leaks, no losses, or contamination during dispatch. This shows the general sampling intervals based on the unit type and application. And you can see for mobile equipment on the road, for example, if we're talking about diesel engines or LPG engines, we have for routine use, we are talking about 15,000 miles or 250 hours. If it is intermittent use, we are using quarterly sample. So this is agreed upon during the initial setup of the program. So based on the application, if it is on the road, as I said, it is this much. If it is a non-engine equipment, for example, we are talking about 30,000 miles and 500 hours for routine use, and so on and so forth. So this is set prior to the starting of the program in order to have scheduled sampling for testing. Of course, this can be changed during the operation due to the analysis reports and the results obtained and the trending taking place on the machinery involved. So after the samples have been dispatched, the samples are received in the lab and testing will start. And after the testing starts, data analysis will take place and interpretation recommendation coming from the lab will be provided to the clients. So the in-service oil testing parameters usually monitor 3 major points. The fluid properties, and these fluid properties involve the physical properties of the fluid. The most important will be the viscosity. And then there are other things like flash point, like pour point, if necessarily, and water content, acid number, and so on. Then spectroscopic properties like FTIR, and then additives. What type of additives are used for anti-wear, anti-foaming, anti-freeze, and so on and so forth. Then the oil condition monitoring program will be looking at contamination, and the contamination can be from dirt, from environmental conditions, all right? Or it can come from water ingressed from atmospheric conditions or whatever, combustion products from the fuel itself or from excessive heat, and coolant and fuel coming into the oil. So these we classify them as contaminants or classified under contamination. And the oil condition monitoring program of in-service oil testing look at this particular thing. And then there are the debris. The debris are either for wear metals coming from different types of wears, like sliding wear, abrasive wear, or whatever the type of wear which is there, and the components of the equipment itself. So we are looking here about the type of debris, and we can classify them with different techniques, like, for example, SEM EDX, which is using X-ray spectroscopy, or we are using, for example, ICP, or we are using rotating disc electrode technology, and so on and so forth, and particle count, ferrography, and so on. So oil condition monitoring program covers these 3 major streams of testing and provide results. After the results are being produced, there are data interpretation for cause and effect, and what to do as well. So we provide you with probable causes for such change in the oil, and recommend certain actions, like, for example, resampling, topping up, draining down 25% of your oil and topping up with another 25% of fresh oil, and so on and so forth, or ask you to change the oil or increase the frequency of testing. All of this type of things comes from the results being produced from the testing and the cause and effect techniques we are using for analyzing the results. If we are talking about viscosity, and viscosity actually is one of the major or the most important parameter tested, because actually lubrication is about lube oil is about lubrication, and lubrication is related to viscosity. So during the operation, you will be having the results either going low or becoming high. And the reasons for low viscosity is low viscosity grade is being used as a top-up, or contamination with fuel or solvents, or decomposition or degradation of the oil to break down during to excessive heat, for example, or as the sample was taken in from a wrong place or was mislabeled or whatever. And in that case, this is the case we have to retake the sample to ensure that this is not a wrong result. If it is a high viscosity, again, it can be related to using a high viscosity grade oil in topping up the machinery, or there will be excessive oxidation as a result of aeration or excessive heat resulting in the formation of big polymers or whatever, contamination from soot, for instance, or sometimes polymerization. And all of these type of things could result into plugging of your system, all right, and increase of friction, resulting in more wear at the end of the day. Water, of course, is something people don't want to see it in their lubricants. And as a result, the damage that can happen from the water, from foaming, from plugging of filters and so on, should be avoided. And the water can come from atmospheric condensation, leaks, okay, ingression from water wash during washing of the machinery or whatever, steam leaks when we are talking about steam generators or whatever. We are talking about poor deemulsibility, and this is seen when you don't have VI improved oils, and any inaccurate sampling involved. Additionally, acid number and base number. Acid number is a parameter where we are measuring the acidity of the oil. It shouldn't exceed a certain level. There are additives to control the acid number, all right? And for certain engines, as we mentioned earlier, for particularly diesel engines, we are measuring the base number, which is related to the acid number. And the additives here is to control the acidity to avoid corrosion. And acid number increases because of high oxidation, all right? And we want to actually decrease the acidity of the oil to avoid the corrosion and the damaging results afterwards. The acid number can be related to the wrong oil being used and contamination with other fluids, and of course, testing variability involved. Other parameters which are very important now are the metals. The metals in the lube oil are classified into three categories. They are either additives, which are built in the formulation, and these are either detergents, okay, and we can see barium, magnesium, sodium, and calcium involved, friction modifiers like molybdenum, anti-foam and anti-wear additives like phosphorus and zinc. So most of the people will say barium, magnesium, calcium, phosphorus, and zinc are the major additives used in lube oil formulations. Contaminants coming from cooling additives, like which you can see from sodium and boron, for instance, dust and sand, and you can see high levels of aluminum and silicon, unnecessary sometimes, so you can relate them to the contaminants in there. And if there is hard water involved, high levels of calcium can be seen, along with magnesium, of course. Wear metals, which are coming from wear, are either structural, coming from the components or the alloys of the machinery itself, and the major items there will be iron, manganese, nickel, chromium, aluminum. Bearings, so if I see copper, chromium, aluminum, nickel, tin, or lead, this is related to the bearings, bushings, and pistons and stuff like that. Aluminum, copper, and tin are one of the some of the elements which we can see from testing the metals. We offer a suite of 21 metals, can be extended further if we need, using different technologies in our labs, like, for example, ICP OES, inductively coupled plasma optical emission spectroscopy, or the rotating disc electrode optical emission spectroscopy as well, these are two techniques which are the industry standards for measuring them. In addition to this, we offer other services for debris and like particle size, like ferrography, and so on and so forth. So again, in certain oils, like the turbine oils, for example, particle count is very important, which actually particle sizing. And this is done by two different techniques, which are basically either laser scattering techniques, but we call it optical particle counting, or we can do something called physical pore blocking particle counting as well. These are two techniques used in the industry as well. Of course, the optical one is superior, but it has limitation on the particle size limits or the high levels. But this can be discussed further if somebody has separate questions later on. BV has a unique solution for the oil conditioning monitoring program using artificial intelligence, which we are calling CHARS. CHARS actually use the machine learning aspect and procedures by digging into a wide range of information and results, historical results. Thousands of results are being digged into this, and trends are being made in order to provide the clients with more information, which cannot be actually found from just regular checkups. So if you have a machine which is 10 years old, for example, and you have been running a program for a very long time, all the information for these 10 years will be digged in using this CHARS technology, and patterns and trends can be helpful for you on the long term, meaning more meaningful information can be produced digging into the historical the results of a certain equipment. After this is shared with you, it goes to the LOMS. On the right side here, the LOMS is our reporting portal, which is Lube Oil Analysis Management System. We'll talk about it in the reporting part. So CHARS helps you get a wider view of our wider picture, or look at the wider picture of your machine and the oil involved by grabbing more information from more data involved. This, of course, cannot be done except by the machine learning programs we are talking about. So the objectives of CHARS is providing you with the ability to process more samples and more data and focus on those which are critical. So it actually filters the information. It gives you consistency in terms of the uniform comments coming out and flagging of the results, and the rating of the severity of across the laboratories being tested, even if you are using different laboratories and the data are available in your system. It can give you a better level of recommendations as well based on the trending taking place. Reporting is a very important part of the system of oil condition monitoring program, or the program itself. And we are using LOMS, and LOMS can be accessed from your iPhone, from your smartphones, for the iPads, from the desktop, from wherever. And this is basically a portal where we upload the results on this portal, and you can monitor the sample schedule and the submitted samples as it is going on. You can view the test results as they are uploaded in the system. You can do filtering of the data as per your need. And most of our clients, for example, they have a focal point who are having access to the LOMS, and he will be giving access to his subordinates or teams. Each division will be having an access to the equipment they are in charge of. So it's not necessary for the whole team to look at all the data of the machinery when you have many of them. It will be related to the division itself. So basically, the account holder of the LOMS can actually give access to individuals to look at the machinery, to do the trending, and actually be involved in the programs later on. So the reports we are producing through the ROMs will include all the information related to the piece of the equipment. It will be having the company name, the workplace, where is it, the unit ID, the manufacturer, the model, and so on and so forth. When is the sample being taken, and when the results have been produced. And at the end of the day, it will give you the results. This is, for example, for the wear metals, contaminants, and additives for debris, for example, for the wear metal analysis. And you can see the results are actually at several dates, starting from 17 to the 2017, 2018. It gives you the levels associated with each element involved, classified as per wear metals, like here, and the contaminants like silicon and aluminum and sodium coming from, for example, cooling system or water, and the additives involved like barium, calcium, magnesium, phosphorus, zinc, molybdenum, and boron. And at the end of the day, based on the results, you'll be having a flag on the status, which shows you red as an urgent, means urgent action has to be taken, and orange, which is caution, means you have to be careful, maybe take another sample, reduce the intervals of sampling, or have a closer look at your machine to see what's going on. There is a probable damage happening soon. And if it is normal, you will be having this sign as green. So nothing to be taken, regular checkups, and as per the scheduled intervals has to be in place. So we have many clients using our services, and some of the clients are listed here, like Emirates Steel, ADNOC, Crescent Petroleum, Emirates, Etihad, OOCP, and so on. And I leave the floor for the questions here. If you have any questions, please use the chat button so I'll be able to answer it as we go.
Thank you,
Thank you very much. And sorry for the disruption which has taken place.
So thank you, Sharif. We're waiting for actually.
Yes, there's already, sorry to interrupt, Nana, but there's already one question from Rushidan regarding, do you have any sampling pumps, vacuum pumps that can cater for IV, ISO, VG 320 and higher?
We can provide our clients with the sampling pumps. Basically, we can have, we have several sampling equipment. We didn't go into details, but I'll be more than happy to share the sampling pumps we are using. We can use actually handheld sampling pumps or other ones, depending on the application, depending on the sampling point itself.
Is there any further question? If there are actually no further questions, I would suggest that we end the call. Please don't hesitate actually to contact us. We would appreciate if you really spend some time actually answering our short survey post the call. All people registered via the registration link would be also receiving actually the recording and the presentation used today. And yeah, if there is any issue or if you don't receive it, don't hesitate to contact us using contact.middleeast@bureauveritas.com. I think, Sharif, in the previous slide, we are also sharing the direct email in which the client can contact for inquiry. So basically, if you have any specific inquiry or very specific question, if you can go back to the previous slide, Sharif, please. You can use also this attached email, which is ocm@bureauveritas.com. So thanks a lot, Sharif, for the very informative presentation today. I think also many of our guests today have also shared same feedback. Thanking you for such inclusive and informative webinar. And yeah, I'd like actually then to wish everybody a very nice day and hope to see you joining us soon in one of our upcoming webinars. Thank you so much.
Thank you very much. And if any further information is needed or questions to be asked you, please contact us on this OCM Bureau Veritas. And of course, the topic would require more information. We have other technologies to discuss if you want separately. So if you have specific questions, please shoot it on this email address and we'll be more happy than to answer them, please. Thank you very much.
Thank you, Sharif. Bye-bye.